All right, so we need to plot all our points here. So I had my students just write down in degrees of 15, going all the way from 0 to 360. And then each of these, remember the height was the whole distance of our radius of our circle there. And so each of these are a decimal. And we're just writing down the information that we got. So at at 0 was on the ground. At 30 degrees here, we said it was 0.5. At 45, we had 0.7-ish, so somewhere around there. At 60 degrees, we had around 8.5. At 90, we actually had perfectly at 1. At 120, we had around 8.5. At 135, we had around 0.7-ish. Oh, that was 0.7 there too, wasn't it? Here we go. And then we had, 150 was 0.5 and 180 was 0, because remember that's where we actually touched the ground. Then we went underground here at 210. We were way down here at negative 0.5. At 225, we were at 0.7, 0.85. Oops. 270, we're at negative 1 exactly. At 300, we were at 0.85 again. And at 0.7 and at 0.5, and then at 360 we were back exactly at 0. So if I were to make a nice little sketch filling all these little guys in here, I would have this beautiful looking wave going on here. Look how pretty that is. All right, and so one of the things that you need to also do is to do the calculated height. So to look back at your circle was like this. At, say, 30 degrees here, this was 30. Remember, this whole thing was equal to 1 here. And we were finding out what this distance was. Well, this is the opposite, and this is the hypotenuse, which would put us at sine. So sine of 30 would be equal to the opposite over the hypotenuse is equal to 1. So in other words, it would just be the sine of 30. So that's kind of cool that I would just need to put in sine of 30 to find my exact answer. So then we look at another one and we say, okay, but all right, what about when it was like up here at 60 degrees? So at 60 degrees, this is still 1 because that's still my radius. This is still my opposite here. So I would still use sine. Sine of 60 is now equal to opposite over, well, we'll put an x there, over 1. So it's still sine of 60. So what we find is to find any of these values here, I really just want to use the sine of whatever degree I am. So we check it and we say, all right, well, that's kind of cool, but what if we wanted like the sine of 240? Is that really going to give me a negative? And sure enough, look at this. It's negative 0.866, and we said it was around 8.5, so we were pretty close in our estimation. So what I did is I said, well then, if every single one of these points is really the sine of whatever angle we have, it's really like saying the sine of x is equal to y, whatever those values are. So if I go into my y and I write sine of x, and then I graph this, check it out, that looks exactly like what we've got going on here. So what we've really done is we have created the sine graph. How cool is that?